Hi everyone, and welcome to PyData Meetup 6. It's really nice to meet you all, to see you all here. And I'm going to talk a little about what I did with Clickstream data in my company. This is the conclusions from a research project we did, which goal was to understand how we can leverage Clickstream data for our purposes of understanding our users. So who are we? I work at Bluevine. What do? We do loans for small businesses in the United States, and we are really awesome at it. And the reason we're awesome is because we are fast and accurate. And why? Because the vast majority of our decisions are automated using machine learning models built by my amazing team. So it's really nice that everything is automated and great, but in every automation there's always the gray area of things, the area where we can decide automatically. And on this part we let the analyst decide manually. So in order to increase this area of decisions which are not automated yet, we need to make our models better. We need to make our data better. And one way to do it is to take wider amount of sources, more types of sources of data. For example, today what we usually do to decide whether to give a business a loan, we look at these bank reports, at statements, at credit report, at the web presence of the business, all kinds of things. But something pretty unconventional would be to look at the clickstream of the business owner in our website to try to understand the behavior of the user. This is pretty unconventional in our field, and that's why this is still an ongoing research and it's not deployed to production. But still, I think from my research, many people here can see what they can do, how they can leverage clickstream data for their purposes. So our journey with this Clickstream data will be with the 5 steps. The first step would be to explore the data and define the goal, what we want to do with it. Then we will see some examples of what kind of cleaning and preprocessing this data needs. Then we will explore how does a user session look like, and from that we can understand what kind of features do we want to build to analyze this data. And then we will try to engineer some features and see are they correlated with our target, with what we want to predict. And the last stage will be to try and build a model from these features to try to predict something that is of interest to us. And besides create a model, I always like to try to analyze the result of the model and see what actually this model have learned in this process. So first step, we want to explore the data. So the data I had is data for Mixpanel. Anybody here knows Mixpanel? Do you know what it is? No? Wow. Okay, so if you are product people, you probably know Mixpanel very well, because this is a service that tracks all the user actions in your website. It actually takes the digital footprint of where the user clicked and which page they visited and records everything. And what's really nice about it, that for us, it can track the user actions even before the user is registered to our website, just based on the cookies of the users on his computer. And the fact that this was a tool that was developed for product purposes, this poses a bit of a challenge for me, because I want to analyze it for other purposes, which is understanding things about the users. For risk purposes, risk evaluation. So we would see the problem this poses for me. How does our data look like? So actually Mixpanel, it has a really nice UI, which the product people at our company use to see the funnel and all the stages and how much time every step takes and everything. But what I used is a database where all the user actions are stored. And what you can see here, this is a data frame of a sample of data I took from this database. And I have all different columns here. I have the properties ID, the distinct ID. This is two kinds of IDs that by which I try to recognize the user and cross it with the user in our system. And we have the time and the URL, which means this is the action, that the user visited this URL and this time. And we also have all kinds of events that product defined, and all kinds of properties which I don't look at. It's not interesting for me. Actually, the only data I need from here is the ID, the URL, and the time. And now I decided to focus my research on a very simple thing, which is to predict whether we will approve or reject this business from giving it a credit line, a loan from us. This is the first decision we do about every business that comes to us. Later on, we have more decisions we have to do about the user. But to simplify things, I decided to focus on this. Now, usually how this works in our company, we gather a lot of information about the user, as I said before, bank and credit reports and all kinds of things about the users. And by using that, we decide whether we approve or reject, either by automatic rule based on a machine learning model, or by analyst for the minority of decisions. So in this case, I decided to try to predict our decision about the user without looking at the regular data sources we use, only by reviewing the Clickstream data. Okay? So what I did is to take the target, which is whether the user was actually approved or rejected for funding by our analyst. And my data, my features, was just the Clickstream information. I tried a few directions. I will take questions in the end, okay? I tried a few directions in my research. And these are a few directions that didn't come out well in the end. But I took some insights from them. For example, Markov chain analysis. What does it mean, Markov chain analysis? It means that you look at the transitions the user did between one URL to another, and you try to build a probabilistic model by looking at users which were approved, looking at users which are rejected, and mapping the probabilities of transitioning from each URL to another URL for these kinds of users and for the other kinds of users. And then by that, you can build a model that says who is this user more likely to be, approved or rejected, using these two matrices of probabilities of transitions. So we tried that. It gave nice results, but it wasn't perfect. It was pretty mediocre. And the main issue with it is that it wasn't so interpretable. It was hard to say why the model decided as it did. So I looked for something which I would be able to understand more. The other things I tried, mostly because I know that everyone is now talking about using deep learning for sequence classification, because we actually have a sequence, right? The timestamps with the URLs. It's like a sequence of events that happen. So you can use an LSTM, for example, which is a recurrent neural network. It's a network with memory which is really good at analyzing sequences. So maybe it will detect something in these sequences and see which users are likely to be approved or rejected. But the problem with the deep learning is that it requires usually big data, a lot of data. And Bluevine, what's so nice about it, we have really nice businesses which are our clients, and some of them even have credit lines of up to $2 million, but we don't have very big data because of that. We have a bit smaller scale than what's usually used for deep learning. I don't know exactly, but I can say that I read some papers about it, and companies that usually do use sequence analysis using RNN for Clickstream data, they have it's like usually ad companies that has like millions of clicks per day, and we have like at least a scale less than that. So I think that was one of the reasons this didn't work out that well for us. And And another reason I didn't want to use it in the end was because, again, it is very hard to interpret. If you want to understand why the LSTM decided as it did, then it's really hard. There aren't really good tools that does that. So the final strategy I chose, and that's I'm going to talk a bit more now, that was just an intro, is to engineer feature myself, use our business wisdom, what we know that can be interesting about users, build these features manually using Pandas, like we'll see, and then train a machine learning model based on these features, not just take the raw data of the actions, but create the features and use the model on them.
Is it a classification problem, or you did a regression to?
I did here. It's a classification problem. It's two class, approved or rejected. In the end, you get a probability.
Yeah,
you always get a probability. Yeah. So you can think now, what kind of features can be interesting in this case? I mean, we are looking for. Sorry, everyone who's speaking, you have to speak with the microphone. Okay. So. What are you looking for, actually? Say that you have one user that come to, what do people do at our website? If you're a business owner and you want to get a loan, then you get into our websites, and what you need to do is to fill in some wizard with the details, and then after a few hours, you get approved or rejected. So, for example, one user can come to our website and read all the information about, and all the details and all the in the blog of Bluevine, or I don't know, all kinds of things, and then go to the wizard. And another user can just go to the wizard, but do the wizard very slowly. Maybe it will take him a long time to fill in the financial details. Maybe he will go back and forth in the wizard. All of these things are things that might be interesting for us. Maybe these are patterns that can somehow be connected to the nature of this user and to his future financial behavior. So these are the kind of things I looked when I built my features. So as I said, we have to do some cleaning and pre-processing for this data for all of this to work. And this was a bit of a large data for me. It was about 10 gigabytes. So for Pandas, it was a bit borderline. But I used a few tricks, but it worked. But maybe if it was a bit larger scale, I would use Dusk or something like that for parallel computing. And I had a few challenges in the cleaning pre-processing. I had to map the IDs to the users in our system. I had to look at the URLs. Now, URLs are usually not that clean as you would think. They sometimes contains user slugs or all kinds of marketing keywords and all this stuff you have to clean because you want to be able to recognize different URLs repeating for different users at different times. So you have to do all this cleaning. So we will see an example of that. There were also many duplicates, so I wanted to clean them. Also, I wanted to cut the data in the right decision point because I get loads of data, all the clicks for all the users, but I want to predict only the decision about the user. So if I will use data from after the decision point, it will ruin my model because then I will see things I'm not supposed to see, right? It's like a data leakage. So I had to understand where exactly do I have to cut my process. I will take questions in the end. And the most important thing is to identify user sessions because maybe a user got into our website a few times before it was approved or rejected. So I want to be able to distinguish between different user sessions. So let's see what I did. First thing, as I said, I wanted to clean the URLs. Now, if I look at the URLs, are you able to see this from there? Yeah. Okay. So these are the most common URLs. You see they look okay. But if I look at the less common URLs, then you can see I have all kinds of slugs and all kinds of marketing keywords here. So I want to clean all that. So what did I do? I used this really nice, efficient Pandas string commands. They have They have all kinds of string commands like split and replace and all this stuff that you can see here. And also they have regex. So I used regex to clean, for example, here the user slugs. So it's really nice and a way to do it very efficiently on large data frames. And now you can see that the less common URLs, they are all nice and clean. So this was one of the steps I did in the cleaning. And another very important thing I had to do is to understand the time differences between the actions the user did. I want to get to know the users, so it's interesting for me to see how long did it take him to do every action, right? So for that, as I said, I had to clean the URLs and clean duplicated URLs. And then I wanted to just calculate the diff between the timestamps, right? So then most native way to do that would be group by user and then a diff, like you see here. Well, this is nice, it works, but if you want to do it faster, and I wanted to make things a bit faster, so you can do it also without group by. You can just sort all the data by the user, then sort it by the timestamps, and then just do the diff, and then just remove the first row for each user, the one row which is not correct because it's timestamp difference between the user and the previous user. So this is just a trick, and it's 10 times faster because it saves us the group by. So this is nice. And then after I have the time differences between actions, besides that now I know how long did it take the user to do each action, now I can understand how to distinguish between different user sessions, because I want to understand what is the behavior of the user, what is the average time the user does on a session. Like, does it take him a few hours or does it take him a few minutes? So to be able to distinguish between sessions, I looked at the usual time diffs of the users. I did this distribution plot, the cumulative distribution plot of the time differences. And what you can see here, the times are in minutes, that most of the time differences in my data were up to 1 minute. 90% were up to 1 minute. And then there's a long tail for this distribution until around 30 minutes. And also I know that the website just logs you out after 30 minutes. So I thought that deciding that if the time diff is larger than 30 minutes, that then I define that this is a new session for this user. Okay? So now I know how to separate between sessions, so I can try to characterize all the sessions for a user. And what I can see here is just an exploration I did, that you can see I mark the new session every time diff which is more than 30 minutes, it's a new session. And then I count the sessions using CumSum for each user. And I can see that until decision, most of the user had up to 4 or 5 sessions until the decision point, until they were approved or rejected. So this is just interesting to look at. This is also one of the features I later used in my model. How many sessions did the user do until the approval or rejected? Now, the step 3, I will go through this really fast. This is just an example of the user. In order to get some, I don't know, motivation or intuition about what kind of features would you like to build, I looked at the actual user session until approval to see what it did in our website. How does it look like? And I actually chose the user which was a bit problematic. It took a few days to approve it. It usually takes less. So this is a user which was manually approved, like all my data. They're manually approved users. And it's also a bit more problematic in the users which are manually approved. You can see that the first session here, you can see here the time and the URL. And he just came in and read about Bluevine line of credit. He didn't do much. Then on the second session, it was a day after, he went in and started doing the wizard. And as you can see, he did some back and forth in the wizard. And he didn't finish the wizard. He didn't get to the last page. He got stuck on the business or personal details. I don't know why. And then, this was a few days after, he did the wizard again. And this time he finished. Took him about 30 minutes. And then after an hour after he finished the wizard, he got into the website again and just went into one URL in the website. So it's interesting. I guess he probably wanted to check whether he's approved or rejected or whatever. And then we can see another hour later, again, he's looking at the dashboard, looking at the Flex credit page, browsing through the pages, but still is not approved. And again, and again, and in the end, he was approved 2 days after. So that's just to give us insight to how this really looks in real life. And now let's look at the feature engineering, some example of the features I did. So first type of sessions, and the major part of the features I engineered, are features that are around the session, trying to understand the characteristics of the session per user. For example, the duration of each session, it's interesting. The number of pages the user visited in each session. The total number of sessions the user had until the decision about him. And also the specific, where at the time he did the wizard, how long did it take him to do the different parts of the wizard, and whether he finished the wizard, and how many times he did the wizard. All these things are interesting.
First two is an average?
I will, actually the first two I did maximum, minimum, median, and min. These were all the features. And I just did all of them. So for example, this is the median session duration. And I'm just showing how you can do it really nicely with Pandas. So you can see that I just did group by the user. I also group by the session number because I want to group by per session. And then I take the maximum time for the session minus the minimum time. And this gives us the session duration. And now you can see for each user, for each session, you can see how long this session takes. This is a session number. And after I have this, I just have to decide what I want to do. Do I want to do median or maximum or minimum on this data? So after I have the session duration here, I converted it to seconds. And then again, I group by the user and I apply median. I do reset index and then group by the user and apply median. And now for each user, I get the median session duration, which is what you see here. These are the seconds for the median session duration. So that's nice, but how do I know this is worth anything? How do I know this is actually connected to what I want to predict? So I can just throw it to a model. But I wanted to review the data a bit, do some exploration. So I did two things. One, I did box plot, and two, I did a statistical test. And this is, for example, what I got. This is the box plot. And what you can see here is this is the box plot of the time, the median session duration of the approved users, and for the rejected users. This is the time. And I also run a F-test, a NOVA, which detects whether two distributions are different from each other, or the degree of linear dependency between the feature and the targets. These are two things, same things. And what you can see here that there is a significant difference between the approved and the rejected users. So actually, the median session duration for rejected users is usually larger. So that's interesting. I try to understand why. Maybe it takes them longer to fill the details. They have to bring more. Maybe they are frauds, so it takes them time to commit. I don't know. I don't want to say. So they won't sue me, but I don't know. So that's interesting. That's one nice feature you can get. You can also look at the maximum or minimum or average. Yeah, all our clients are from the US. Maybe they do it from China, I don't know, but the business have to be from the US. Okay, now another example of feature I looked at and got into the model also is the number of pages visited in the shortest session. So again, I also tried the minimum, the maximum, the average. Here I showed the minimum. So what did I do here? Again, I took my data frame, I grouped by the user and the session number, and this time I looked at the URLs and just applied length on all the URLs I have on the list of URLs, and from that I get the number of pages the user visited in each session. So you can see here, for this user and each session number, how many pages did he visit? Here visited 77 pages in one session, but they're not unique in this feature. So that's what you can see here. And then you can apply on this whatever you want, minimum, maximum, median. So for example, here I applied minimum on this. So I got the shortest sequence number for each user. That's what you can see here. I do a reset index, and then I group again by the user. And then I take the minimum of the number of pages in the session. And then I just get the shortest session for each user. And you can see here an interesting phenomenon, a bit reversed from what we saw before, but it's not something else. If you think about it, it's something completely different. You see that for rejected users, the shortest session is shorter than the approved users. So what I thought that the rejected user, maybe they need the money more, so they do more short sessions that they just come into the websites and check, are we approved, and just check, visit just one page many times. So this is what I thought, but again, I can't tell. So, but it's interesting. You can see that it has correlation with the target, so it's interesting. So this was two examples from the session features. And other features I used are, for example, URLs. Just looking at the URLs, because you don't have to browse our whole website when you want to apply. So maybe it's interesting if someone read all the terms of use or the blog, maybe it says something about him. So I just did Boolean features for each URL the user visited, and I also did it in a nice, efficient way with Pandas. I just grew by the user. Then I do value counts for appearances of each URL, as you can see here. Group by, then URL value counts. This is the number of time the user visited each URL. And then I use the nice command I love, unstack, which is just taking the rows and putting them into columns. It's really cool. And then for each user, you get these Boolean features of 1 and 0. It's supposed to be the number of time the user visited each website if you use value counts. But I wanted them to be Boolean, just yes or no. Did he visit it or not? So it just did larger than 0 here. So this is a nice trick to do these kind of things. I use it in many scenarios, this value counts and unstack. So you can take it as a tip. And other types of features that I developed, the number of times the user visited the app and the website. It's the two types of pages we have in our website, the app and the website. And also, besides the URLs the user visited, also the sequences of URLs he did, because sometimes it means differently. If you go from one page to the other, it's different than you go from the first page to another page. It has meaning. It can have meaning the way you do. So I put also Boolean features for this, the sequence that the user did in our website. This was also, I got the motivation to do it from the experiments we did with Markov chains, because Markov chains is actually looking at the transitions between URLs. So because I saw that Markov chains were partly useful, I thought that this kind of feature can help and give some more interesting information. And I built these features also in a similar way to what I did with the URLs the user visited. So I won't show it. And the last thing I want to talk about before doing the model is data leakage. Data leakage is the thing that in every project I always have in the back of my mind, and I think every data scientist should always think about that. I'm trying to build a model that will help us decide about the user, whether its financial behavior will be good or bad. But I want to give us extra information. I don't want to tell us what we already know about the user. I want to give us to use only the information we know at the time point of the decision, because if I would use other information, then it wouldn't help, right? It would just learn something that I don't really have on real life. It wouldn't work in production. And then I thought, after I built all this feature, maybe some of my features are not right. Maybe they are somehow leaking the target. And one interesting thing that I saw, when I looked at this time to decision, I saw that it can maybe leak the target, because if you look at the approved and the rejected user, if you look at the decisions which are automated, of course, the decision time is very fast, because this is some model that runs and just say yes or no. But if you look at the decisions which are not automated, the time to decision is somehow larger for approved users. I don't know why. But it's interesting. And then I thought, if I have this interesting correlation with the time to decision, maybe some of my features are correlated with the time to decision. If they are correlated with the time to decision, and the time to decision is correlated with the target, then yeah, time to decision of the analyst about.
It's more scary to approve than to reject.
Yeah, probably. But so if my features are correlated with the time to decision, and the time to decision is correlated with the target, then maybe my features are somehow revealing the target. I need to eliminate the part of the features that actually can tell me the target. I'll give an example. If it takes a longer time to approve a user, and I have a feature which is the number of sessions the user did until approval, then it's natively, if you take a longer time to be approved, you may do more sessions, right? Just because you have more time. So that I want to eliminate from my model. So how I fix that? What you can see here is that I try to understand whether it is really true. I looked at the session number, and number of sessions until approval versus the time to approval. And there's not very strong correlation, but there's a bit of correlation. So I wanted to feel okay with it. So how I just got rid of it, it's just not using the number of sessions until approval or rejection. It's just using the number of sessions in the first 24 hours of this user. Then I won't have dependency in the time to approval. And then you can see that now the number of sessions in 24 hours and time to approval, it has no correlation. So I fixed that. And I did it also to other types of features which were correlated with time to decision, like number of visits in the website, number of visits to the app, all kinds of features which are similar to this. OK, so now we are in the last part, where we build a model and look at the results. And what I did here, this was a research project, so I didn't do a very wide model selection. I just took my go-to model, which is, of course, XGBoost. And I just throw all my features, all the features I selected, which was good enough that passed the statistic test, and pushed it into the XGBoost algorithm to build me a model. And what we see here is the ROC curve in here. This is the false positive rate and the true positive rate and the random guess in red. And we can see in blue the train ROC curve, and in green the test ROC curve. And this is actually a pretty amazing result. It's a bit unreal. As we see here, this is also a graph I like to look at besides the ROC, the probabilities plot. As we said, this is a classification algorithm, but it gives us a probability. So these are the probabilities for the bad class the rejected class, and this is the probability for the approved class, and we can see that there's nice separation here. These are really nice results, much better than anything I can find using Clickstream data online. So I got a bit suspicious. And like always, I looked at the feature importance. You can take this from the XGBoost straight. And I saw that the most important feature here, it's a very weird feature, is I put many features like the number of the number of session of 2 pages the user did, and which pages did he visit in these sessions. So this is a session like this, the number of time the user did 2-page session and visited the page of settings file and login. So this actually means, when I check what it means that user that visited this page was actually asked by our risk department to give us more information. So if he was asked to give us more information, probably his situation wasn't that good from the first place. So that's why the model decided this is an important feature. But in fact, this is not a very useful feature because it tells us what we already know, right? It doesn't give us extra gain on what we know. So I decided to move all the features which are related to this. And that's why it's very important, to my opinion, to look at the features decision from this model and to try to understand the model decision before we just throw it to production. And then I just removed all these related features and ran the model again. Now we got these results, which are less nice, but they're actually more reasonable. They're more aligned with what you would expect from Clickstream data, which is pretty magic, right? Just looking at the clicks of the person and understand whether we should give him a loan, it's really crazy. So, so now we got 68% instead of 78, which is nice. And there is still some separation here, which is really nice, I think. And if we look at the features, the important features, we can see that one of the most important features are the time it took the user to do the financial part of the wizard, which is interesting, I think. We can also see that one of the important features is the minimum number pages in sequence, the one we looked at, the shortest sequence length. And we can also see an interesting feature, which is the partial wizard session duration, which is actually the time it takes the user to do the wizard when it was a partial wizard, when he didn't finish the wizard. So this is also interesting, I think. Another thing I like to do, besides looking at the feature importance, is also using all kinds of tools to interpret my model. For example, Lime. I don't know if you heard about it or not. It's a really nice tool developed by these PhD students from Washington University. And what it does, it just gives us explanations per sample. You can just give it the model, give it the sample, and then it will give you the reasons for why the model decided about a certain sample as it decided. So what it gives you is actually features which are most important for these specific samples. And how it does that, it does some kind of approximation of the model around this specific sample, because models are complicated. They are like XGBoost, they are very non-linear functions. So it looks at a specific sample and does an approximation of the model function around this sample with a linear model. And then it gives us the largest coefficient in this model and the coefficient for each feature in the linear approximation. So what we can see here, that's interesting. I looked at the Lime explanation for the users we looked at before. You remember the user we explored together. And we see in blue, there are the good features, the ones that were pulled us to direction that this user was approved. And in red, these are the rejected feature, the features that pulled us to the other direction. Now, this user was actually approved, but as I said, it was a bit problematic. It took us time to approve it. It got probability of 56 in the model, which is in the right side, so it's nice. And we can see here, for example, that the fact that this user had only one session in the first 24 hours this is a good sign to the model because this is blue, what you can see here. It gives us a range of the value for each feature, which was most influential. So for this, it's the range that it's smaller or equal to 1. In this case, I put the X here, so it means it was 1 session in the first 24 hours. This is, by the way, a visualization I did. It has other visualization. I just want to do something that you can see the ranges of the values for the features. Other interesting features you can see here is that the unique app count, for example, the unique pages the user visited in our app is smaller than 7, then this is somehow a good sign. Again, I'm not sure why or if it's good, but it's interesting to look at. And the partial wizard session duration, remember this user did the wizard twice. He did it one time, he didn't finish, and one time he did finish. So this is like a bad feature that this took him a long time, longer than 800 seconds. So this is a nice tool to try to understand the model. So you're welcome to check it out. It's open source. And that's it, actually. I just summarize. So I think Clickstream data has a lot of interesting insights we can get, and it's just from there. You don't need to pay anyone. You just can get it pretty easily. And from what I saw in the beginning of the project is that deep learning is not always suitable for every application, especially in application when you want to be able to interpret your results and your model decision. You can see that you can do many cool things with Pandas and very efficient things, even on a large data set. And you need to be always aware of the fact that data leakage is out there coming to get you. And you need to always try to understand your model and its decision using different tools. Even looking at the feature importance can be very valuable. And the last thing is, well, that's it. I said everything. Okay, so thank you very much. I would take, we have time? Yeah, if you have a question now, I can, yeah.
Well, first, I think you did like really amazing job. It was very interesting. I have a few questions. How many URLs did you have?
In the website? I don't know exactly.
Did you cluster them, or you just?
No, I did not cluster them.
And did you try any process mining tools?
Like what?
Like from Disco to visualize the process and see the main patterns and sequences?
No, but it's interesting to try.
Okay.
Yeah.
And did you use ngrams on the sequences, or like?
No. I just created Boolean features on all the. I didn't have that many URLs. I guess that if I would have many URLs, maybe I would try to use something like Word2Vec, maybe to encode them in a more smart way to give it to the model. But I use just the sequences.
One sequence is like 8 actions, and one sequence is 20.
No, I just use short sequences of 2 or 3 URLs at this point. Yeah.
And the classes were balanced or really unbalanced?
It was not perfectly balanced, but it was okay. It was enough. Actually, XGBoost is the model I used. It works well even with the classes which are in balance, like up to 1 to 10. It's okay. It's still okay. Yeah, 1 to 10 is still okay from my experience. But 1 to 100, you may want to balance your data. Yeah.
So, like, I'm curious, like, how you interact with, like, let's say, for example, the product team changes the way the application works, and suddenly some URLs are gone and some new URLs come in. Like, how is your interaction with them, like, the rest of the company to make sure that that won't, like, screw the model?
That's a great point. We're actually just changed the whole registration process in our website, so that's why this model is not used right now in production, and probably we have to retrain it now when we want.
If they change the automatic logout time, you can ruin the...
I don't think they changed that, but they changed the registration process. So yeah, that would ruin the model, and you have to build it. But I guess if this will go in production, we will have to somehow automate all the feature selection and retrain the model all the time. Yes?
You said that the model only looks at people before receiving the answer. What about repeat customers that come once again for a second loan? Is the model applicable? Is this considered a data loan?
Well, it's a good point. Right now, this is just the primal stage of this research. So I decided to focus on the first part, which is until decision. If I want to apply this model on repeat users, I have to build a better model using all the data from after the decision, I think. So this was just the primal thing to do, but that's true. Yeah, you can use it further. Yes? So I talked about that. I looked at it. I calculated time diffs of the user actions, and I looked at the distribution of the time differences, and I saw that the long tail ends around 30 minutes. And I also knew that 30 minutes is the logout time from our website, so I decided that after 30 minutes, I define a new session for the user.
The samples are the aggregate sessions of the user, like all the sessions, or every specific session of the user is a sample?
The features I use are the features I generated. I don't use directly the data as is. I generated the features as I showed you, and this is what I put into the model. The URLs the user visited, the median session duration, the sequence length, all these things.
The feature considered all the sessions of the user?
Until the decision. Yeah.
24 hour.
Yeah, but some of the things are also after the 24 hours. Everything which is not dependent on the time to approval, then it's also other, but also after the 24 hours.
And did you consider the time of day when the user was in the site?
I didn't use it as a feature, although it's interesting. I use it in other models. You would think it would be interesting, but for now we didn't find a strong correlation with this feature. One last question. Yeah.
Question, if I may. You mentioned that you're trying to predict the final decision made by the analysts or your existing model. Wouldn't that be kind of predicting based on noisy labels? Because what actually interests you as a company is whether the loan was returned.
That's true. Yeah. But for now, I just decided to focus at this stage. If I will further this model more later, then I will probably use the final situation of the user, whether it's good in the end or bad in the end. But I just try to focus it and see if I can understand things that the analyst understand on the user just from the behavior of the user, just proof of concept.
What's the difference between you and a company like Pandas in terms of the business model? Because they also do small business credit lines.
Well, they're kind of competition to us, Funbox, but we do larger loans. We do large-scale loans. They do small loans. Okay. Well, that's it. Thank you very much.